Most children don't even know what the traditional virtues are. Courage, for
Mm.
example. These are virtues. These are things that you can actually cultivate as habits. And because education is supposed to be value neutral, and it's left to people's religion or private conscience or family or something, most people don't get any religious teaching anymore at home or in a church or anywhere else. And and some school teachers would be afraid to teach any of these things for fear of being accused of imposing their personal subjective values or ideology on children. So the result is there's a kind of moral vacuum, and it's very harmful, I think.
Welcome to Rethinking Education. Education's critical friend.
Rupert Sheldrake, welcome to the Rethinking Education podcast.
Good to be with you.
It's great to have you with me. It's making me smile, sort of saying that out loud, because I've been very immersed in your books recently. I've read a few of them and listened to quite a few, and I've listened to quite a few of your podcasts and other podcasts that you've been on, and so it feels a little bit surreal to be speaking with you. So it's lovely to be able to spend some time. So I reached out because as I say, I've been reading lots of your work and really enjoying it. And there were a couple of books that you wrote quite recently, one called Science and Spiritual Practices and Ways to Go Beyond and Why They Work. And although they don't really speak directly to education, it feels to me like there are some sorts of educational implications to the things that you're writing about. And so I'm quite curious to see where this conversation goes, but so yeah, we'll see what happens. But what I often like to do in this podcast is to get to know the guest, and obviously for our listeners and viewers to get to know you if they're not familiar with you. So could you please firstly just give a very sort of brief introduction to yourself for anybody who may not be aware of your work so far?
I'm a biologist, and I spent almost my entire career as a practicing scientist. I was educated at Cambridge to start with. I did history and philosophy of science at Harvard. Then I did a PhD in plant biochemistry at Cambridge, and I was a Don and director of studies, a fellow of Clare College in Cambridge. So I had a kind of academic science training and practice. Then I felt I wanted a rather more adventurous life than just going on being a Don at Cambridge. And I had a job in India in an international agricultural institute working on the improvement of chickpeas and pigeon peas. I was called the principal plant physiologist. And I was running field experiments and working with the team on crop improvement, plant breeding, to improve agriculture for some of the poorest farmers in the world. When I was in India, I got very interested in Indian traditions. I did yoga and meditation. I had a Sufi teacher for a while in Hyderabad, which is where I lived. And then while I was at Cambridge, I had an idea called morphic resonance. I'll come back to that, the idea of memory and nature. I wanted to write a book on it, so I left my job for a while and lived 2 years in an ashram, a Christian Benedictine ashram on the bank of a sacred river in Tamil Nadu in South India. So I lived in I had a very happy time living in this, very simply, in this community. Then I came back to England basically and worked part-time in India. My first book, A New Science of Life, came out in 1981, was quite controversial. And since then I've been doing research mainly in biology, but also in rather underexplored areas of psychology, including parapsychology. I've written quite a number of books. I'm still very active in scientific research. I think 6 or 7 papers last year in peer-reviewed scientific journals. I'm working on 2 or 3 more at the moment. So, I'm very active in this area.
Right. Thank you. That's really interesting. And so yeah, you're right. We will come back to that stuff later on. I think that it makes sense in your case to start at the beginning. And so I'd like to take you back to your own experience of school. Where did you go to school? What kind of school did you go to?
I was born and bred in Newark-on-Trent in Nottinghamshire, and my father was a pharmacist and a herbalist. And when I was born in 1942, and so soon after the war, he and a group of other parents set up an independent school because they didn't think that the state one was very good, and started an independent day school, primary school in Newark, which I went to, called Highfields, called Newark Preparatory School. So I think I was well taught in sort of basic education there, sort of all the basic things you do at primary school. And then at the age of 10, when I'd done the 11 plus and so on, but my parents sent me to a boarding prep school, which was the preparatory school for Worksop College, an independent school in Nottinghamshire. So I was at this prep school called Ranby House for 3 years, which, being away from home at the age of 10, seemed normal at the time, but now I would think of it as really rather odd. And then I was in an all-boys boarding school, Worksop College, 50 boys sleeping in the same room in a big dormitory, somewhat military type discipline, corporal punishment, compulsory cadet force, compulsory rugby 6 days a week, whatever the weather. So it was a classic minor public school, authoritarian, disciplinarian, fagging prefects, all that sort of thing.
Right. And how did you find that? Because for lots of people now, that would sound just horrendously austere, and that it might be, considered to be borderline abusive.
Yes, well, I just took it for granted. This is how it was. This is in the 1950s. I left school in 1959, and at the time, most schools had corporal punishment and boarding schools. Basically, it was soon after the war. Many of the masters, it was a boys-only school. Many of the masters had been in the war, the army or the air force, and so there was definitely this post-war feeling about it, and discipline was important, and so, well, I didn't particularly like all that, and it didn't suit me temperamentally very well. The emphasis in the school was on the highest prestige went to boys who were good at rugby and games, and it was rather anti-intellectual, the atmosphere.
Right.
I got very well taught, though, because most of the teachers, when they found someone who was actually interested in learning and curious and wanted to know more, which I did, they responded in a way that I felt I got a really good teaching from really good teachers. So I felt I was very well taught there. The social atmosphere of the school and stuff didn't suit me very well. Wasn't very keen on compulsory rugby on days when the ground was frozen, and when you were tackled, the frozen earth cut into you, causing bleeding and stuff. I mean, all that stuff. It was designed to toughen us up.
Character building, they would have called it. Hey.
Yes, they called it character building. Yes, and toughening us up, and I think it did toughen me up. A lot of things in life after that seemed pretty mild by comparison with school. However, once I won a scholarship to Cambridge, and in those days you had to stay on for a third year in the sixth form to do Cambridge scholarship or entrance exams. But as soon as I got that, I left, and I got a job in London as a lab technician, and like a gap year before I went to Cambridge. So I had a kind of classic education of that very old-fashioned all boys type.
Yes. And was it always going to be science for you? Was it science from a young age?
Yes, my father was an amateur microscopist. He had a microscope lab at home. He taught me the names of plants. I kept lots of pets, animals, tortoises, pigeons, a rabbit, mice, hamster, a jackdaw. I had a lot of animals, pets, budgerigars. We had a dog. So I was really into plants and animals. That's why I did biology. And then through my, actually a kind of brought out a kind of rebellious streak in me, because I noticed that the first thing we did in biology classes was to kill the things we were studying and then cut them up. There was a lot of dissection in those days in biology. And then the job I had in the lab, I was so keen to get experience. I wanted to be a scientist, lab experience. For my gap 9 months, I wrote round various drug companies saying, "You got a job for a temporary lab technician?" And one of them wrote back and said, "Yes, someone's just left." And so I got the job. And then I found I was the most junior technician in a vivisection facility. And it was my job to gas all the animals that survived the experimentation and toxicity tests at the end of every day. And so I was basically operating a gas oven for a kind of animal holocaust, which was appalling because I'd gone into it
Yeah.
because I loved animals. And so it set up a tension in me between kind of mechanistic science, animals are just machines, plants are just machines, we're just objectively dealing with mechanisms. And the fact I actually loved animals, that's why I was doing biology. So
Yeah.
it made me much more questioning of what I was taught when I got to Cambridge than I might otherwise have been. And
Yeah, interesting. I had a very similar experience, you know. I worked as a lab technician while I was at university, and it was in a very sort of non-scientific role, but it was a lab at UCL where actually that was when I very first saw you because you did a talk at UCL back in the 90s. But yeah, I had to go and collect the animals in the animal house and dispose of their carcasses. And I used to, see them on electrophysiology rigs, like a rat with its sort of brain open and loads of wires going into it, and it's
that's
sort of anesthetized, and it's really just I don't even know what word you could describe it. It's sort of just grotesque. Like it's really an unpleasant thing to see happening, and in just such an everyday thing, you just go through dozens of animals a day in that way,
exactly. Well, you see, there's something about it was like a rite of passage. I mean, like medical students at university have to dissect, I think they still do it, dissect a human corpse. It forces you to become emotionally detached in a way that most biologists and medics have something they've gone through, produces this kind of unnaturally detached attitude to life,
Mm.
which is necessary if you're going to have a mechanistic theory of life. Well, even if you're a non-mechanistic doctor, it's good to know the anatomy, and I suppose doing dissections is the best way of learning it. But the anyway, for me, this was it played an important part. I liked the practical exams on the whole. I liked practical lab practicals in physics and chemistry very much because I really enjoyed learning through doing. And there's less of that in science education now than there used to be. But learning through doing seems to me really, really important. And science was almost the only thing, apart from physical education, where you could learn through doing when I was at school.
Yes. Yeah, absolutely. It's something that I resonate with as a former science teacher. We just had this brief conversation before we started recording, but yeah, the learning through doing, the kids would love practicals. They would always turn up to a lesson and say, "Oh, we're doing a practical today." And then your heart would sink thinking, well, you are doing a practical, but that practical involves following a series of 5 instructions. And if there's no mystery in it, it's not really learning by sort of experientially finding stuff out. It's just that you're following a preset procedure, and then you need to wash your equipment away and go and write it up in this pre-specified way. And so the learning by doing stuff really wasn't happening. Yeah, I agree. That's not happening to the extent that it should.
Incidentally, the writing up thing, again, the traditional way of writing scientific papers, a test tube was taken, the passive voice. Um,
Yeah.
it's, I was taught to do that. I learned how to do it. But when I got to Cambridge writing real scientific papers, I found that most of my colleagues didn't do that anymore. It had gone out of fashion. But when my son Merlin, who's now a well-known mycologist, wrote a wonderful book called Entangled Life, when
Yeah.
he was at
Brilliant.
school here in Hampstead at University College School, he wrote brilliant science reports when he was in primary school, and when he got to secondary school, they were all written. It actually said a test tube was taken, it was carefully heated with the substance in it, and then smelled. And so, as if some disembodied being had smelled it. And so I said to him, why is your science report written in this incredibly artificial, old-fashioned style? Because that's the way you got to write science reports. And he showed me a specimen sheet his teacher had given them, and he learned it. And I then took this up with the science teacher and said, you don't really need to do this. Real scientists don't do this. And he didn't know that. He said, what a relief, and started teaching the active voice. I then did a survey of secondary schools in Britain, of heads of science, of about 200 schools. And of them, about 30% of state schools were teaching, enforcing the passive voice, and about 60% of independent schools. And some state school teachers said, it's hard enough to get my students to write anything at all. He said, so I can't force them to, unfortunately, I can't force them to use the passive voice because they wouldn't understand what it is. He felt he was a failure for not enforcing the passive voice. And I showed this to the president of the Royal Society, Lord May, who was president at the time. And he was appalled. He said, no one should be forced to write in the passive voice. He said, in this day and age, it's a sure hallmark of second-rate science. And Nature started editing scientific papers into the active voice at least 30 years ago. And almost all I did a survey of scientific journals. I only found one out of 50 that insisted on the passive voice, and that was a minor and rather obscure journal.
Isn't it interesting? And I've noticed a similar pattern. I now read more social science than natural science, but that same sort of format where people, for example, if they refer to their own previous work, they would say, Mannion 2019 wrote such and such, as though Mannion was somebody else rather than me.
Yes.
And it's it feels like you're trying to create this illusion that you are an impassive pair of eyeballs or consciousness that is just sort of objectively noting down reality, and your own situated nature is just sort of erased out of it. And it just seems like it's a ludicrous conceit, and that it's unhelpful, really.
It is a ludicrous conceit. And I mean, science is done by people, and an experiment is something you actively do. It's not something that unfolds passive in front of you, the passive observer looking at nature through a plate glass window.
Yeah.
Anyway, I think one thing that there are still, I did another survey just about 5 years ago, and I found there were still a lot of teachers enforcing this, not because they believe in it, but because they think they ought to. And I checked with all the examination boards, edXL, whatever, RSA, or whatever they are, the different examination boards, Oxford and Cambridge, and not one of them required passive reports. Most of them said they were neutral. And so no one's insisting on this. Certainly journal editors aren't insisting on it. And yet there are still quite a number of science teachers who are insisting on it. Those who gave it up as a result of our surveys, and an article I wrote in the School Science Review and in New Scientist about this, a lot of them gave up doing it and said, what a relief. And
yeah, there's a new version of this, or a sort of slight variation on it, which is that there's this endless focus in school science about independent and dependent variables and control variables, and we try to sort of to teach this from year 7 upwards, that there's the thing you change, and that's the independent variable, and then there's the thing you measure, and that's the dependent, and then there's the control variables. And as an adult, it's quite easy to grasp that, but as an 11-year-old, it's really not. And you spend absolutely hours and hours and hours going over this, And, you know, I later worked at Harvard Medical School in a big multidisciplinary lab. Nobody ever once mentioned like independent. What's the independent variable in this? It's just not what people. It's just not the language that people talk about, and it was just turning people off science. And I came across a really interesting thing a while ago. I don't know if you come across a guy called Ivor Goodson, who
No.
is an education social researcher, and he uncovered this really interesting bit of history that was like in the 19th century. There was a thing called the science of common things, and it was very much sort of about exploring the local fauna and flora, and just doing hands-on practical stuff, learning by doing, like you say. And there was Lord somebody or other. I'll send you the link to this thing after this call if you like, because it's really interesting to read. Who did a report and a survey, and he went around schools, and he went to a school where and was speaking to this this a kid not from a public school, who had been doing this science of common things, and he said that this child issued forth an answer of such eloquence and insight that far exceeded his station in life, because he was this sort of emaciated little oik from the street corner. And so he went back and wrote this report and essentially said, we need to change the language and to change the way that science education is presented. And it's now this sort of like this watered down version of laboratory science, using things like the passive voice, like you say. And there's lots of stuff about test tubes and conical flasks and things that don't exist in people's kitchens or lives. And it sort of all became removed, and we still have that to this day.
I know, very much the detriment of actual understanding of nature. One thing you mentioned in our preliminary conversation is that, when learning about the stars and learning about the heavens, most children learn about it from textbooks, and there's pictures of rockets and things, but they don't actually go out at night and lie down and look at the stars. And I suppose because it's after school hours, but in the winter, when it gets dark at 4, wouldn't be very after school hours to look at the stars. And I was at an adult education centre in Canada about 20 years ago, and they had a naturalist there on the staff, and he said, let's do a star talk. And so I thought, okay, I've never been to something like this. And we went out, he had blankets, lay down on the beach. It was near the sea, and it was a nice warm evening, clear sky. And he just, with a torch, a strong torch like a pointer, just took us through the constellations and the planets. But I'd never had that education. I got a PhD in science, and I've never, ever had anyone explain to me the night sky. And because most modern astronomy is radio astronomy, and it's all based on sums and calculations. I was once at a party with the then Astronomer Royal at Cambridge, and there was some particularly brilliant heavenly body that I didn't know what it was. And I said to him, what's that? He's Astronomer Royal. He said, don't ask me, I'm only an astronomer. He said, I do radio astronomy. And he didn't know the constellations. The only people who know it now are celestial navigators, and even they don't learn it anymore, people on yachts and things, because they've got sat-navs.
Yes.
So just learning about the stars by seeing them and being at night, and learning about plants and animals, and learning about the soil by digging things up and looking at roots, and this kind of basic learning. When my children went to school, this kind of thing stopped at the end of their reception year. In reception, they had a nature table, and it was all right to sort of put birds' nests that had fallen out of trees there, and things that children had found, and stuff. But from then on, it was all about the body as a machine, and you've got to learn, how the heart's a pump and that sort of thing.
Yes.
So I think a huge amount more nature learning would be really helpful. I mean, because then it brings it close to real living animals and plants, which is what biology is meant to be about.
Yeah, absolutely. And also, there's something else that we spoke about off air, which was about the atomized nature of the school curriculum. And we see that across the curriculum, where you have geography, history, art, maths, drama, as though they're all separate things. when actually in the world they all overlap, and there's very little, well, really not any interdisciplinary learning that happens in schools, at least not officially. There's an interdisciplinary university that's just opened up, LIS, London Interdisciplinary School, which is really interesting, but that's largely absent from schools. But we see the same phenomenon as well within science education, and it often, you sort of rotate around biology, chemistry, and physics. So you do forces 1 minute, and then you do, like the alkali metals the next topic, and then you're doing, whatever it might be, photosynthesis. And again, it's all really atomized and sort of disconnected. And I know that you've spoken before about how you describe your worldview as holistic, or your understanding of biology as holistic. Please, could you explain what that means and how that is distinct from the sort of the mechanistic model that you were just describing?
Well, the mechanistic model, which is still the dominant paradigm or model of reality that's taught in science and practiced in science, is that nature is a machine that basically causes by pushing and pulling, and there's no purpose in nature, no purpose in evolution. The mind's nothing but the brain, the body's a machine, the heart's a pump, the lungs are like bellows, the eyes are like a camera. All these things are true as far as they go, but it just involves looking at everything through the lens of the machine metaphor. And it's only a metaphor, it's not a testable hypothesis. You couldn't do an experiment that would prove or refute the idea nature is just a machine. It's just a metaphor. It's not a scientific hypothesis as such, but it's become deeply embedded. Ever since the 17th century, it's been the fundamental metaphor of science. But it's not the way nature actually is. And if you look at the way nature is, first of all, it's obvious that animals and plants aren't machines, they're living organisms. And they do have purposes. If a dog's hungry, it looks for food. And it's also clear that nature's organized in a series of levels. If you look at the small level, then you have subatomic particles in atoms, nuclei and electrons. And then you have molecules which contain atoms in the molecule. And the molecule is more than the sum of the atoms. The water molecule is more than the sum of hydrogen and oxygen. And then you have crystals, which are more than just the molecules. Ice is more, especially a snowflake with this beautiful six-fold symmetry, is more than just hydrogen and oxygen atoms, or even more than just water molecules. And then when you get to living cells, the cell is more than the proteins and DNA and lipids and things within it, and a tissue is more than just the cells because it's got more structure and organization, and organs more than the tissues. An organism is more than the sum of its organs. They all work together harmoniously in an overall form with overall purpose. And then a group of organisms, like a flock of birds or a hive of bees, is more than just individual animals. It's the whole unit functions together. And then ecosystems, and then planets, and then solar systems. A solar system is more than just planets and the sun, they're all working together. And then a galaxy made of stars is more than just a bundle of solar systems. It has a structure, a pattern. So everywhere you look in nature, there's levels of wholeness more than the sum of the parts, and each of the parts is a whole at its own level. And so that's basically the holistic worldview. And there are certain properties that wholes have, that all wholes have at all levels. They're always more than the sum of the parts. And the wholeness somehow organizes and coordinates the parts so they work together harmoniously. So that, I think, is the basic way nature is constituted. And when we look at it that way, then we can see physics deals with very small wholes, atoms and subatomic particles, and basic forces like gravity and light, and also with very large things like cosmology, the cosmos, galaxies, stars and stuff. And chemistry deals with sort of bigger wholes than atoms, molecules and ions and crystals and things. And biology deals with living wholes, from bacteria and microorganisms up to the most sophisticated animals. So I think when you look at it that way, it's easier to see how things fit together, and it's easier to see how there's a common pattern. to the way everything's organized. And we're used to it when I was a child, I used to write those addresses, our house, our street, our town,
Yes.
Nottinghamshire, England, the United Kingdom, Europe, the world.
The outer
The solar
spiral arm of the
system.
Milky Way.
Yes. So, every child understands that this sort of, and the higher level isn't just arbitrarily a higher level as if some level's been arbitrarily promoted, so it's in charge, like a kind of someone who's jumped up, a dictator or something. It's a higher level because it actually includes the lower ones. The solar system includes all the planets within it, and a tissue includes all the cells within it. It's not. So these higher levels are inclusive levels of organization.
Yeah, I see. And so let's talk about morphic resonance and about how this sort of, because as I mentioned earlier, this idea of significant learning, the big ideas that have shaped our lives. I think that's probably the one that has most shaped your life. So can you take us back to the origins of it? You said that you had the idea while you were at Cambridge. What was the sort of the gap, if you like, in the mechanistic worldview that you thought that there's something that's missing here, that you think that morphic resonance is an explanation as to how things are the way that they are?
Well, at Cambridge, I was working on plants and plant development. The reason I was working on plants was partly because I love plants, but also because I didn't want to spend my career guillotining rats and killing animals, which research in zoology or medicine would have involved. So botany or plant biochemistry were for me much more attractive fields to go into. So I was working on how plant form develops, and I'd worked out there's a hormone called auxin, AUXIN, indole acetic acid is its chemical nature, which is a key hormone in plant growth and development. And I worked out how auxin is made, and I discovered it was made by dying cells. That when cells die, the proteins break down, autolysis, they have proteolytic enzymes, and the levels of free amino acids go up because the proteins are breaking down. And then amino acid destroying enzymes kick in and break those down. And one of the amino acids is tryptophan. It's present in animals and plants and bacteria. And when it's broken down, it's transaminated or deaminated to give indole pyruvic acid. And indole pyruvic acid breaks down spontaneously or by fairly non-specific oxidases to give auxin, indole acetic acid. So dying cells make auxin. And the main dying cells in plants are the wood cells, which become dead empty tubes. And as they differentiate, they produce auxin. And then it's transported from the shoots towards the roots by a polar auxin transport system. And at Cambridge, I worked out how that works too with a colleague called Philip Rubery. This is in textbooks now on polar auxin transport. We worked out the means by which it happened. So I was, very pleased and excited, and we were ahead of anyone in animal studies. We knew what the key chemical was, we knew how it was transported, we knew the chemistry of its production. No one in animal development knew those kinds of things at the time. But then I realized that it's explained too much. All plants have auxin and polar auxin transport systems, ferns, conifers, palms, cabbages, roses, beech trees. And all parts of the plant have the same auxin production and transport system, the leaves, the flowers, the shoots, the roots. Yet the leaves are different from the flowers, and a beech tree is different from an ash tree. And so this, which everyone said the molecular basis of development, everyone's hopes were pinned on auxin to explain it all. And I realized it just can't explain why they're different. It explains why they're similar, why there's a coordination of the tubes that conduct water, the right number of tubes to feed the growing leaves, etc. But it doesn't explain the specific form. Then I got interested in an idea put forward first in the 1920s of morphogenetic fields, form-shaping fields, that there are fields that shape form like an invisible mold around a developing leaf that would cause it to be a leaf shape, or around a developing petal that would cause it to be a petal shape. Like a magnetic field has invisible lines of force and shapes the space around it. The idea was that in plants and animals there are these form-shaping fields which help to shape form. Um, and I thought they're top down. The field causes, it's not just bottom up molecules bumping into each other, somehow creating the form just from genes and proteins, which the reductionist approach still insists is the way forward. But there has to be a top down organizing system, these fields. So then the question is, how are these fields inherited? Because they can't be inherited by genes. Genes just code for the sequence of amino acids in proteins or for switching on and off other genes. So I always thought genes were overrated. I was teaching this stuff at Cambridge,
Yeah.
but
I was sorry to interrupt. I was quite sort of pleased to hear you say that, because as a biology teacher, and my degree was biology and psychology, and I was doing it, late 90s, around the time of the Human Genome Project, and there was all this fanfare, and then I was teaching this stuff as a biology teacher shortly afterwards, and protein synthesis, like you say, like DNA just codes for amino acids, which string together into proteins, and how does that describe a biological organism, organ systems? There seems to be like layers of organization, like you were saying, in this nested hierarchy: tissues, organ systems, organisms, and then societal levels of like behavior and so on, that are just the genetic explanation that this is the brain of the cell and that this controls all of life. There's just lots and lots of leaps in
yes,
that chain of explanation.
exactly. It doesn't make sense when you think it through, but most people still take it for granted. So anyway, when I was trying to think how could these be inherited, they couldn't be inherited through genes, and I didn't think they could be eternal mathematical equations, because biology is all about evolution and changes with time. So some biologists, theoretical biologists who'd switched from being mathematicians, believed that everything's governed by eternal mathematical laws. And mathematicians tend to be Platonists. They believe there's a kind of eternal mathematical realm on which everything depends. So I couldn't believe that dinosaurs had eternal dinosaur equations there at the moment of the Big Bang and still present today, but it was only a matter of accident or chance that dinosaurs actually existed. This way of thinking that it's all about the maths didn't appeal to me. So then I thought, well, how could they be inherited? And at that stage, I read a book by the French philosopher Henri Bergson called Matter and Memory, written in 1898 or 96, where he argued that memories are not stored in the brain and that there's a kind of causation, a memory causation directly across time, with not necessarily anything in between. And then I realized that if there was a kind of resonance across time, each organism could have a kind of collective memory of form and of instinct, and that many mysteries to do with instinct, inheritance, and indeed memory itself, collective memory, would be explainable. So this was my hypothesis of morphic resonance. The idea is that at each level, the wholeness is governed by a field, an organizing field. The generic name for these is morphic fields. Morphic means form, so it's to do with fields of form. And that these fields of form got their structure through a kind of memory from previous similar systems. So a giraffe morphogenetic field be like an invisible blueprint for a giraffe, and a giraffe embryo would grow in accordance with it. But that field would be like a collective memory of the actual form of past giraffes. So basically, in its general form, this idea is that the so-called laws of nature are actually more like habits. There's a memory in nature. Well,
And
this is
just in case anybody, because the first time you hear this idea, the first time you come across it, it sounds like it's so far removed from the mechanistic understanding that, like you say, most people sort of accept without really thinking about it, that it's hard to grasp. Please, could you share just a couple of sort of examples of what types of phenomena we see in reality that this field, this idea of morphogenetic fields, explains in a way that materialist sort of billiard ball nuts and bolts science doesn't?
Well, for example, the theory predicts that if you train lab rats to learn a new trick in London, then as soon as they've learned it in London, similar rats all around the world, in America, in Australia, in India, and elsewhere, would be able to learn the same trick quicker, just because the rats here have learned it by morphic resonance, kind of collective memory. And there's actually evidence that happens. And to put it even more close to home, the theory predicts that when the Wordle puzzle, the 5-letter Wordle puzzle, is published every morning by the New York Times, as the day goes on, as millions of people solve this particular 5-letter puzzle, it should get easier to solve. So it should be easier to solve the Wordle puzzle in the evening than it is in the morning, other things being equal. And there's an MSc student actually doing a project on Wordle from this point of view as we speak, as a test for morphic resonance. In the realm of chemistry, it means if you make a new chemical for the first time and you crystallize it, there won't be a morphic field for that crystal lattice structure before. It hasn't happened before in the universe, as far as we know. You may wait years before one appears. Often it takes months or years to get a thing to crystallize. Once it's crystallized, it should be easier for that chemical to crystallize all over the world. And actually, there's many examples from chemistry of where compounds are very difficult to crystallize, but once they've started crystallizing, they get easier all over the world. And chemists usually say, well, yes, of course that happens, but it happens because fragments of previous crystals nucleate the crystallizations elsewhere because they get wafted around the world as invisible dust particles. So what I'm saying is that filter out invisible dust particles, it should still happen because of morphic resonance. So basically, those so-called laws of nature, I'm saying, are more like habits. And although in the West, this is a very hard idea for people to grasp, when I was working in India, I already was thinking about morphic resonance. When I explained it to my Hindu colleagues, instead of shock and horror or just puzzlement, they said, oh, of course, that is the way nature is, karma, the influence of the past. Hindu and Buddhist philosophy has this idea of a memory in nature as just standard. I'd meet people on trains in India, after they ask you, what is your name, where is your family, that kind of thing. They then start on, what is your view of the world or the universe? The Indians like these conversations and got train journeys lasting hours. So I'd explain about morphic resonance, and almost always people would just say, oh, yes, that is what we think. We've always thought that, our philosophy and so on. So it was far from shocking in India. And it's a peculiarity of our Western worldview that this has got baked in to science.
Yeah, it's interesting. And lots of the questions that you ask seem to me to be just really reasonable questions. But like, for example, like in the science delusion and in your TED talk, which was famously banned, you were talking about big G, like the gravitational constant, and how the accepted value of big G, which is considered to be a universal constant, the value for it has fluctuated over time quite considerably. And the official argument is that we've just got better at measuring it, and that's instrument errors, rather than you're suggesting that, well, what if big G is actually fluctuating? Which just seems like a really reasonable question to ask, but people seem to be outraged by the question even.
Yes. Well, I mean, some people are intrigued by it, but people who've made science into a kind of religion, scientism, people who've made, Richard Dawkins is an example of someone who's made science into a kind of religion. They're usually militant atheists. And there are lots of atheists who aren't militant, but the militant type tend to be believers in scientism, and it's become for them a belief system that's part of their identity, and any challenge to it makes them angry. I get this reaction a lot, of course, because I do a lot of challenging of it. But with big G, yes, they get more and more precise, and the measurements they publish have these tiny error bars. But then when someone else comes along with a precise measurement with tiny error bars and it's somewhere up here, then what's going on. So my proposal was simply that instead of publishing the average value from a lab over months or years, they publish the raw data. And it could be that all around the world, on a particular day, big G's higher, and on all around the world it may be lower on another day.
Yeah, because isn't there some sort of are they called metrologists, the people who collect
Yes.
all these measurements, and then they do stuff to the data, they average it out, and they do sort of adjustments to take account of what they think is real and what's not, and so you arrive at this figure that, like you say, it's not raw data.
No, oh no, it's not raw data. It's averaged in each lab, and then there's an international committee averages for the ones from different labs around the world, weighting ones that they think are more valid. If it comes from Cambridge or Harvard, and so counts more than if it comes from the Ivory Coast or something. So, they end up with these average values. And next time the committee meets in 5 years' time, the average values are different. So they're always changing them. And in those handbooks of physical constants, which are constantly being updated, they have the new values of the constants. So my point was not that, just simply that what if the Earth, as it travels through space, maybe there's, some physicists now believe in dark matter, mysterious matter, we don't know what it is. What if we pass through a cloud of dark matter? This would affect measurements of G. And maybe it's telling us something about the Earth's environment as it moves through space. But by refusing to look at the fluctuations because it's got to be a constant, this is just narrowing down science. And that's why in my book, The Science Delusion, I take the 10 fundamental dogmas and turn them into questions and say, well, what happens if we look at these scientifically instead of just saying they must be true?
Yeah,
And
absolutely.
then science opens up, it gets so much more interesting.
My favorite question is that book. In that book is there's a chapter on consciousness, and you were talking about like materialist philosophers and people like Daniel Dennett who wrote Consciousness Explained, but it was really sort of consciousness explained away, where he said that it's just, it's not really a thing. It's just it's almost like a Darwinian, there are things that we attend to, and the stream of attention is just the stream of winners in that Darwinian race. But there's nothing really to see here, and that it's just this sort of, it's explained in that billiard ball mechanism. And at the end of that chapter, you ask a question and you say, so do you think that your views on materialism, your views on consciousness, are determined on this billiard ball level, or do you feel like you've arrived at them through reason and argument and creativity and what have you? And it's a really, really good question, because they don't seem to be applying the same principles to what it is to be a materialist. It seems to it sort of eats itself.
It eats itself. You see, well, they managed to imagine that they're on the side of this plate glass window as an objective observer of reality, somehow detached from it.
As they were taught to write in the passive voice.
A disembodied mind, yes. But somehow everything else is mechanistic and materialist and stuff, except for them, people like them. I think that's one reason why Stephen Hawking became so iconic for people who are not scientists, and indeed for scientists, because he was the closest you can get, through no fault of his own, but through his own misfortune. He was the closest you can get to a disembodied mind as a human. And he became iconic of the scientific quest. On his book, A Brief History of Time on the Dust Jacket, Time magazine is quoted by saying, even as he sits helpless in his wheelchair, his mind soars through space and time to unlock the mysteries of the universe. So the idea that a disembodied mind could somehow soar through space and time to unlock the mysteries from a vantage point outside nature, somehow, a God's eye view, is somehow baked into the materialist view. So it's not consistent. From the point of view of science education, I think the questions that I deal with in the Science Delusion would be really good questions. The trouble is that no science teacher I know has taken them up in school, because it's not on the national curriculum. It would probably do more harm than good to, A-level rankings or GCSE rankings. So they don't do it. Occasionally I'm asked to talk about these things in schools, and the last 2 or 3 years, the school that's most into what I'm doing and where I've given talks is Eton. And I've dressed the whole of the lower sixth at Eton for the last few years on the science delusion.
Right.
And they're really up for it there. Whereas when I've tried to do this at other schools, people are frightened of disorienting the children or confusing them, or so they've got enough confidence at Eton to do this. I don't talk at Eton because I'm in favour of hyper privilege. I do it because it's the only school that's invited.
I was just wondering, I'd like to come back to the educational implications of those books that I mentioned earlier, but just while we're on this, how have you found it? I wondered a few times as I've been sort of reading your work. You said earlier that, like the toughness of being a very, very austere school was nothing compared to what came later. I imagine, for example, we talked about your TED talk, attracting controversy, your book that you said that was described as there was a review in Nature, wasn't there, that said a book for burning.
Yes, an editorial.
Your ideas are considered. Sorry, what was that?
It was an editorial on the front page. A book for burning.
Yes, and I wonder how you found that. Like, it can't have been easy to have sort of had your ideas received in such a sort of an aggressive way.
Well, at first I felt this was completely unjust because I played science by the rules. I publish all my stuff in peer-reviewed journals. I make rational arguments and stuff, and prepared to debate them with anyone. And so, I thought I'm playing by the rules. And then suddenly I found that actually the rules don't apply if you try and challenge some of these dogmas. So the editor of Nature basically said that my work should be, in the end, he said the book shouldn't be burned, but should put in protected shelf of a library, and that it compared unfavorably with other dangerous books like Mein Kampf by Hitler. I mean, that was his. Then basically what he was trying to do was excommunicate me. And the result is, from then on, I couldn't get a grant, I couldn't get a job, and whenever I was invited to give talks in universities, whoever invited me always had a problem with people who tried to cancel me. I've been cancelled many times. Cancel culture is nothing new. It's been going on in science for decades. And so anyway, at first I found this rather annoying, and I just thought it was unfair, because I was playing the game by the rules and they weren't, and yet they claimed to be upholding the rules of proper science. Then I came to see that actually these are not evil people. These are people who just really believe that they know the truth. They believe that science has revealed to them, mechanistic science has revealed the truth. All other approaches to truth, like religion, philosophy, etc., are muddled, superstitious, old-fashioned. The only thing that's right up there with the leading edge of human understanding is science, and they really believe in this. That they're basically fanatics or bigots because of their belief system, not because they've been bribed by drug companies, not because they're conspiracies, but they really believe it. And they're really fighting for the truth. The only trouble is they have such a narrow view of the truth. So I'm in favor of fighting for the truth, but I just think it's a shame if one fights for a half-truth or a partial truth.
Yes. Yeah, I mean, thank you for that. I mean, it always strikes me that you seem to deal with it really quite well. You seem very sort of unflappable in the face of belief, of contradicting views, and you sort of say, well, we were talking earlier about that fascinating conversation that you had with Daniel Dennett and Oliver Sacks, and there's 5 or 6 of you sitting around a table. Stephen Jay Gould. 5 or 6 of you sitting around a table. There's about a 3.5-hour video on YouTube, and it's really, really interesting, and it's worth. But you really sort of hold yourself well in those conversations. Maybe all of that rugby and stuff and that character building stuff in your formative years was sort of helpful in giving you this unflappable demeanor. I don't know.
Well, I think it was partly. I mean, I'm not totally unflappable. Some things get at me, but not. Yes, partly. I mean, partly that character building stuff I think has actually served me in good stead. Partly, I'm a Christian and I pray. I used to be an atheist when I was converted to mechanistic materialism as a teenager. But one of the big things about the Lord's Prayer, which I say every day, is, forgive us our trespasses as we forgive those that trespass against us. Well, I definitely think some people have trespassed against me through these kinds of unfair attacks. So I just ask for the grace not to keep these burning resentments. I mean, resentment is a kind of corrosive thing. It corrodes the soul, and so every day I just try and let go. And you know, if you pray for the grace to do it, I find it's much easier to do. So I don't wake up in the morning feeling resentful and angry, and it's just a much nicer way of living, and it's also
Yeah.
effective in dealing with people who are against what I'm saying. It's more effective not to get angry. It's much more effective to try and discuss it with them. And I studied martial arts at one stage, and I like the idea of sort of going with the flow of what they're saying and trying to take it further, you know, so that it rather than opposing it.
Yes.
You know, when you compare the sort of brute force method of American football with Japanese martial arts, you know, it's a very different style, and I prefer the martial arts style.
Absolutely, be like water and all that.
Mm.
And I yes, and lots of those the practices that you write in those two more recent books that you wrote, Science and Spiritual Practices and Ways to Go Beyond and Why They Work. I imagine have sort of been very helpful for you as well, and they're all practices that you engage in. And I know we've only got a couple of minutes to end on. Just for the benefit of viewers and listeners, there's a number of these ideas you talk about: meditation, fasting, interacting with animals, and so on. But there was one chapter that I think really triggered me in terms of reaching out to you, and that was the chapter on cultivating good habits, about virtues, and about, you know, these sort of these universal ideas around how to be a good person. I don't know whether you have any sort of it's a bit of a vague final question, but what are your thoughts? And I know that you mentioned pilgrimages as well earlier. Maybe you want to end by talking about that. I just wanted to sort of just to land on an educational note. What do you think that we should be doing more of or less of in education to cultivate these good habits?
Well, in the traditional education in the Middle Ages, you know, the people were taught that vices and virtues are habits, basically. They're habits. They're habits you acquire, and they become unconscious. And the seven deadly sins are the worst vices, you know, cultivating greed, envy, lust, gluttony, avarice, pride, and so on, anger. These are bad things to cultivate. And yet the modern advertising industry and social media actually make things like greed and envy virtues, and anger and stuff. And then they taught you the good things to cultivate are the virtues, you know, including prudence, temperance, wisdom, you know, love, faith, hope. So I think most children don't even know what the traditional virtues are. Courage, for example, these are virtues. These are things that you can actually cultivate as habits. And because education is supposed to be value neutral, and you know, it's left to people's religion or private conscience or family or something, most people don't get any religious teaching anymore at home or in a church or anywhere else. And some school teachers would be afraid to teach any of these things for fear of being accused of imposing their personal subjective values or ideology on children. So the result is there's a kind of moral vacuum, and it's very harmful, I think. But one thing to end on, I'd love to just mention pilgrimage, because this is something I'm very keen on. And the revival of pilgrimage, which is going on all over Europe at the moment, and here in Britain through the British Pilgrimage Trust, is reopening ancient footpath pilgrimage routes, walking through the countryside on footpaths to holy places, which can be springs, wells, mountaintops, and also our great cathedrals and churches and pre-Christian stone circles and so on. That it's a wonderful thing to do. I do it myself, and I did it every year with a godson, a teenage godson, until recently when he stopped being a teenager. Every year we went on a one-day pilgrimage, 5 or 6 miles through the countryside to one of the great cathedrals, Lincoln, Wells, Ely, Winchester. Each year we did a different cathedral. And now one of the things the British Pilgrimage Trust is doing is trying to open up the idea of school pilgrimages. There's a few schools that already do them, There's a school near here in London where I live. In year three, their teacher, their religious teacher, who's also Anglican priest, takes them to Westminster Abbey. Year four, St Paul's. Year five, they spend 3 days at Walsingham in Norfolk and visit the shrine of Our Lady, and they walk barefoot. 30% of these children are Muslim. They love going on these pilgrimages. And then year six, they go to St Albans Cathedral. And the chap who leads this, who's called Father Graham, is he's quite charismatic with the children. And he says the children absolutely love it because it's learning by doing. They're learning about history, they're learning about nature, they're learning about sacred places. When they get there, they light a candle and say a prayer, their own prayer, whatever they want to pray for. And he says when he goes to Walsingham, sometimes he sees school groups there where they're dressed up in fake medieval outfits, pretending to be pilgrims. And he says that his children find it so much more satisfying because they actually are pilgrims. And I think that school pilgrimage is a wonderful educational, experiential way of learning, and it's fun as well. So I'm really keen on that at the moment.
Thank you.
Interested. Well,
Sorry,
there's a website called britishpilgrimage.org,
right,
which gives all these different routes. So if anyone's interested, they can look at that, and they can get in touch too, because there's a coordinator now who's helping to coordinate school pilgrimages.
Right, thank you for that. I'll look into it, and I'll put a link to it in the show notes and recommend it to my school-based friends. And I thank you for that as well, because I think it was a recent a podcast that I heard, the podcast you do with Mark Vernon. Is it Mark?
Yes.
And there was there's quite a few about these issues and about just how sort of hidden, how forgotten and in decline churches are, and people don't go to churches, don't go to cathedrals, don't go to evensong. There are all these amazing things, and I've started to re-engage with those things in my local community. So thank you for that, because it's really opened things up for me. I was raised in a Christian tradition, and then sort of, like many people like yourself, became a scientist later on and sort of fell out of the habit of it. But there's all kinds of interesting things that people do. People of faith, they sing together, they pray, they do things that are really good for you that those militant atheists are missing out on. So thank you for reopening my eyes to that side of life.
Good. Well, it's great you're doing what you're doing, and I'm very pleased we had this chance to chat.
Yes, yeah, me too. Well, thank you very much. I know that you need to head off now. So thank you very much. I've really enjoyed this conversation. All right, thanks so much, Rupert. Enjoy today.
Bye for now then, James.
Thank you. Take care. Bye-bye.
Bye.
We have a narrow curriculum which squeezes out the arts. So let's rethink education. There is a lack of imagination and not enough fun. So let's rethink education. Children should be self-directed, showing us their way. Let them lead. Transferable skills should be the core of what we teach. Learn for life. So let's try. Right and not what is required. Let's have fun, let's explore. Let's bring back the love, forget the fear of being fired. We're forced to rank the children as Ofsted ranks the schools. So let's rethink education. We have a lack of agency. We're trapped inside the system. So let's rethink education. A place of transformation that embraces community. School is the heart, a place to dream, a place to play, a place to think and love, feeling free. So